Escape of the Destructive Electrons, presented by Science at NASA. Warning: Earth is surrounded by electrons that can be disruptive to our technology. A population of high-energy electrons inhabits the Van Allen radiation belts high above Earth. While these electrons pose no danger to humans on Earth's surface, where we are protected by the atmosphere, they have been blamed for many spacecraft failures. Electron swarms can penetrate and electrify the hulls of satellites and short-circuit sensitive electronics. Avoiding them is a good idea. To avoid them, though, you have to figure out where they are. And that's a problem, because these electrons can be very elusive. The Van Allen belts were discovered in 1958, and their discovery was one of the earliest scientific achievements of the space age. During solar storms, high-energy electrons in the belts have been known to vanish, only to return a few hours later. This strange phenomenon was first spotted in the 1960s, and it has puzzled physicists ever since. In 2012, NASA launched the Radiation Belt Storm Probes, or RBSP, which have since been renamed the Van Allen probes. Rather than avoiding the radiation belts, these heavily shielded spacecraft regularly fly right into them. Their mission is to discover what makes the belt so dangerous, and moreover, so unpredictable. In the few years since they have launched, the Van Allen probes have made many discoveries, such as the occasional existence of a third radiation belt that no one knew about before. The mystery of the vanishing electrons, however, has not been fully solved. A popular idea among researchers is that the electrons precipitate into Earth's upper atmosphere, depositing their energy high above our planet's surface. But how? What could trigger such an electron rainfall? To answer this question, the Van Allen probes needed help from below. Since 2013, an international team of researchers led by physicist Robin Milan of Dartmouth College have been launching research balloons from Antarctica, each standing more than 8 stories tall. These mammoth balloons ride circumpolar winds around the South Pole, floating as much as 40 kilometers high as they look for signs that electrons are penetrating the atmosphere overhead. The name of the program is BARREL, short for Balloon Array for Radiation Belt Relativistic Electron Losses. The electron rainfall, when it occurs, reveals itself by a telltale glow of X-rays. These X-rays are the byproduct of electrons striking atoms and molecules in the upper atmosphere. BARREL's balloons are equipped with a payload of sensors to observe such emissions. Occasionally, the balloons are in flight when the Van Allen probes pass overhead. Such a conjunction is perfect for this research. The two probes can track the electrons from above, while the balloons do so from below. There were 2 such conjunctions, one on January 3rd and another on January 6, 2014, and researchers put them to good use. Working together, the Van Allen probes and BARREL were able to piece together a means of escape. Electrons were gradually eroded away over the course of several days, in part by interaction with plasmaspheric hiss, wrote Milan and colleagues in a letter published in Nature. Plasmaspheric hiss is a type of electromagnetic radiation, or plasma wave, that can scatter these high-energy electrons down toward Earth. Looking up from Antarctica, BARREL could measure the electrons losing their energy in the form of relatively harmless X-rays. Plasmaspheric hiss was simultaneously observed by both Van Allen probe satellites. There may be other ways for the electrons to escape the Van Allen belts, so the mystery is not fully solved. As 2015 is coming to an end, the BARREL team has completed a 3rd campaign of balloon flights over Sweden in search of more clues. Stay tuned for updates from science.nasa.gov.